Let's begin by recapitulating the last video on the origins of special and general relativity, where we talked about the four basic assumptions in relativity. These were number one, the constant speed of light which came from the Michelson-Morley experiment. Number two, the equivalence of inertial and gravitational masses which followed from the removal of ether for the electromagnetic waves and had to be extended to the Newtonian hypothesis of an ether as well. Number three, the reduction of metaphysical concepts like space and time to physical objects such as meter and clock, which had its origins in logical positivism. And number four, the equivalence of all observers, which was a broad cultural trend following the Protestant Reformation and Enlightenment, and sought to distribute power and authority to each individual instead of selected few kings, queens, priests, and nuns. We then talked about four basic problems of relativity. These were number one, the absence of an understanding of why mass causes curvature of space. Number two, the problems of dark matter and dark energy, which comprise 96% of the universe according to most cosmological estimates at present. Number three, the absence of unity between quantum mechanics and general relativity. And number four, no conception of causality in which deterministic behaviors can be reconciled with occasional occurrences and volitional control. In this video, therefore, we will do two things. One, we will try to show what we mean by space in the semantic view. Two, we will discuss why all the four assumptions in relativity theories are false in general, although they appear true in some cases. We will also explain why they work sometimes and why they don't work in other cases. Then in the next video, we will discuss how the semantic view constructs cosmology quite differently from how modern cosmology constructs the picture of the universe. We will also talk about what we mean by quantum gravity in the next video. The most important takeaway from this video is that there are two radically different conceptions of space and time. The concepts of space and time used in modern science are phenomena rather than reality. The reality is semantic, and interactions in this semantic reality produce the phenomenal world, which includes space and time that are used in modern science. The real space, however, is hierarchical and the real time is cyclical. But the phenomenal space is single-tiered and the phenomenal time is linear. We will rely on the understanding of semantic reality discussed in the previous videos and use it to explain observations and solve the problems of relativity theories. One simple way to illustrate the reality versus phenomena distinction is to think of the perceived world as something being projected outwardly from our perceptual apparatus. This doesn't mean solipsism and idealism because there is still a reality of observers interacting with each other. This reality is depicted here by two movie projectors that project two images of the world. Since there are infinite such projectors projecting a world outwardly, therefore this view is neither pure realism nor pure idealism. The world we see is phenomena, so it is idealism. But the cause of that world is a projector, and there are infinite such projectors. Therefore, there is realism. So we can say that projectors are reality and the projection is the phenomena. The projector is realism and the projection is idealism. Since both projector and projection are present, therefore, both idealism and realism are present. We have earlier discussed the problems of pure idealism and pure realism, namely that they lead to bidirectional underdetermination. The solution to that problem, if we recall, was that we have to treat both observer and reality as persons with choice. That person with choice was depicted in the previous graphic by a movie projector. Each projector is a person, and that person's senses and minds project an experience. Since these are separate persons, therefore there is realism. Since the world is projected by a projector, therefore there is idealism. In the video on the semantic conception of reality, we discussed that idealism is what everything can be, while realism is what everything cannot be. We identified these as the domains of the possible and the impossible. We can now apply this to the present model of reality as projector and projection. If two people can see the same world, then both worlds are possible for them and they are inside the projector. But since no two persons can experience everything that the other persons can experience, therefore two projectors or persons are also different from each other. This difference between two projectors is not a binary distinction because some perceptions are common to both. Since everything is not mutually exclusive, therefore there is commonality between persons. Since some things are indeed mutually exclusive, therefore there is a difference between the persons. Hence, two persons are identical in some ways and not identical or different in other ways. We can say that they are neither completely identical nor completely different. Or we can say that they are both identical and different. This is non-binary logical thinking. It is not incomprehensible because two persons share many of the same ideas and yet all the ideas are not shared or common. Therefore, idealism is within each person as the domain of possibility, and realism is the other persons which are the impossibility for each person. Since everything is defined in two ways as what is possible and what is impossible, therefore realism and idealism are synthesized. It is not pure realism nor pure idealism. This is not the complete rejection of either realism or idealism. The world is in my mind and senses, hence there is idealism. But since there are other minds and senses that I am not and will never be, therefore there is realism. Generally speaking, science is the attempt to explain the phenomena on the basis of reality. This is accepted equally well in both Western and Vedic thinking. However, in Western thinking, there is an abstract picture of reality in the observer, and the reality is the detailed object residing behind that picture, and it causes that picture. But in Vedic thinking, the abstract picture in the observer is the primary reality, and the external world is projected outward from that picture as the detailing of the abstraction, as and when we want to know such details. The big difference arising from this fundamental difference in Vedic and Western thinking is that in Western thinking, external reality is modeled as a physical object, quite different from our sense perceptions. But in Vedic thinking, the external reality is modeled just as a more elaborate version of the sense and mind perceptions. The hypothesis of an external physical object is simply unprovable because we can never get behind the sense perceptions. We can also say that all physical properties in modern science, such as mass, charge, energy, and momentum, along with objects such as particles and waves, are simply unprovable fictions. David Hume had in fact advanced this critique of science to say that all concepts of science are fundamentally unknowable because what we know is sense perceptions and not a particle, wave, mass, charge, energy, or momentum. Immanuel Kant then moved all these object concepts of science into the human mind and said that everyone is hardwired to think of the world in terms of particles, waves, masses, charges, energies, and momenta, which is outrageously false. Only physicists think of the world in terms of physical properties and concepts, and that too after many decades of training. If Kant was right, then every child should be a born mathematician and physicist, and nobody should have any trouble understanding physics or mathematics. Common sense shows that Kant is wrong. On the other hand, common sense also shows that the Vedic system is right because every child thinks in terms of colors, shapes, taste, smell, and so on, rather than in terms of the physics and mathematical concepts. All education begins from color, shape, taste, and smell, and physics and mathematics come much later. Even when they come, they are mastered with great difficulty. The projection of a world from the senses and the mind during the waking state is similar to how the same projection is created during dreaming. This doesn't mean that dreaming and waking are identical. During the waking state, there is an interaction between observers. Since observers are reality, therefore interaction with observers is the interaction with the real world. In contrast, there is a dreaming world which is produced by the interactions within the senses and the mind. When these interactions within the senses and the mind end, then the situation is called deep sleep. Finally, when the consciousness is freed from the waking, dreaming, and deep sleep experiences and can directly interact with other consciousnesses, then it is called transcendent. The dreaming experience is considered superior to the waking experience in the Vedic texts because it is closer towards deep sleep and then towards transcendence. Therefore, the model of the waking reality is constructed based on dreaming. In contrast, the Western realist ideas cannot explain dreaming because there is no interaction with the world during dreaming, and yet the dreaming world is just like the waking world. Western philosophy, science, and religion completely neglect the dreaming experience and relegate it to a hallucination. It was subsequently pushed into psychology, where the mind is separate from the body and kept out of all physical models of reality. All these trends in Western thinking are rejected in the Vedic system, where dreaming is described as a more fundamental type of experience than the waking experience. And the waking experience is modeled consistent with the dreaming experience instead of calling it a hallucination. Once we understand the basic difference between Western and Vedic ideas of perception, then we can talk about how space is constructed in the Vedic system. Whatever we call space is the distance between perceived objects. Since the perceived objects are projected outwardly from the mind and the senses, therefore, the distance between these objects is also a mental construction. We don't do it volitionally in all situations because mind and senses are also material instruments rather than the pure conscious observer. The construction of space is therefore a material process rather than the work of a conscious free will. When the world is projected inside out, then space is just the most fundamental of the projections. This is stated in Sankhya philosophy numerous times by saying that space is the first element projected out of the senses. From space then emerges touch, from touch then emerges sight, from sight then emerges taste, and finally from taste emerges smell. It means that everything which can be seen can also be touched, but everything that can be touched may not necessarily be seen. The best example of things that we can touch but cannot see is dark energy and dark matter. They are dark because we cannot see them, and yet they exert a push that can be perceived by touch. Hence, the presence of dark energy and dark matter points towards something that can be touched and yet not seen. What we call space in Sankhya are the locations in perceptual space. For example, something is upward and something is downward. Something is forward and something is backward. Something is to the left and something is to the right. Then something is a table and something is a chair. Something is a rose and something is a lily. All these names like forward, backward, upward, downward, left, right, rose, lily, table, and chair are the words. And their meanings are the various adjectives like taste, touch, smell, and sight, and verbs such as tasting, touching, smelling, and seeing. Thus, again, we can see that the most fundamental perceivable reality is words. Then, words are elaborated by adding meaning to them. Hence, by space, Sankhya philosophy means a realm of words, and by matter, Sankhya means the realm of touch, sight, taste, and smell. A table is thus projected outwardly, first as a word, then as a touch, then as sight, then as taste, and finally as smell. The space in the Vedic system and modern science are not the same. In science, space is an objective reality, but in the Vedic system, it is projected outwardly from the senses. When Einstein equated space and time to meters and clocks, as we saw in the last video, he equated words to objects. That is not unique to Einstein. This has been the trend throughout Western thinking. All word meaning realities are systematically converted to object property realities. After that, the concept of relative space was created when there is a real space in which observers are interacting, which is absolute and not relative. But if we call each measuring instrument a space, then we will obviously get infinite relative spaces and no absolute space. The absolute space in the Vedic text is the inverted tree, in which each observer is sitting on some trunk, branch, twig, or leaf. The twig is not a branch and the leaf is not the trunk. Therefore, we cannot equate each leaf to the other leaf or any leaf to the trunk, branch, or twig. Therefore, all talk about the equivalence of all observers is simply claiming that trunks, branches, twigs, and leaves are all equivalent. Then we can never know any truth, although we can perceive many things. But in the hierarchical system, the perception of a branch is false if it doesn't align with the perception of the root. The perception of the twig is false if it doesn't align with the perception of the branch. The perception of the leaf is false if it doesn't align with the perception of the twig. Hence, the basic idea of relativism of knowledge is fundamentally false. It arises because the world is taken as objects rather than a projection of the mind and senses, and the hierarchical tree space is replaced by a one-tier box-like space. The moment we flatten the hierarchy, perfect knowledge becomes relative knowledge. But if we keep the hierarchical tree, then real causality is the interactions between the observers situated on the trunks, branches, twigs, and leaves of the tree. This interaction, as we have discussed in the quantum collapse and entanglement video, is caused due to prana. Also, as we have discussed, the prana are studied in physics as bosons. The perceived space and time, namely meters and clocks, are constructions from the interactions of prana. Meters and clocks are not observers, they are the byproducts of observers doing the observation. Einstein's relativity equates the byproducts of the observation to the observer, and then he loses the reliability of knowledge. Prana acts at many levels of the observer. These are called the intellect which judges, the mind which conceives, the senses that perceive, apart from the sense objects that are perceived, conceived, and judged. We can also say that the intellect projects a mind, the mind projects the senses, and the senses project the sense objects. Thus, it is not just a projector projecting an image. It is actually one projector projecting another projector, which then projects yet another projector, and this process repeats many times until the final projector projects just an image. This, as we have discussed in the quantum entanglement video, is necessary because the same thing has to be treated as a space, a dimension, and a thing. The projector is the space from which an image is projected. The projected image is the object, and the connection between the projector and the projected image is the dimension. For example, if sight is the space, then color is a dimension and yellow is the object. If color is the space, then yellow is a dimension and lemon yellow is an object. In this way, the same thing can be called a space, a dimension, and an object, although they are called so from different perspectives. In Sankhya philosophy, the space is called Indriya, the dimension is called Tanamatra, and the object is called Bhuta. This tripartite terminology can be applied many times over to construct a very large inverted tree of concepts. Once we understand that the inverted tree is the real space and observers are located on different trunks, branches, twigs, and leaves of this inverted tree, then we can talk about the qualities of different observers. Each trunk, branch, twig, and leaf is a different type of mind body, which Sankhya calls guna. When an observer is situated on a particular branch, twig, or leaf, he acquires the guna of that trunk, branch, or leaf, which means that they become his mind body. Now, when two observers interact with each other through prana, it is the interaction between different guna. The guna are the counterparts of fermions in quantum theory, and prana is the counterpart of the bosons in quantum theory. The guna are the adjectives of a noun, and prana is the verbs of the noun. Hence, when guna interact through prana, then quantum particles are interacting through quantum particles, or that action is used to determine the nature of something. Sankhya philosophy describes that guna come in three basic flavors called sattva, rajas, and tamas, as we have discussed in earlier videos. When two observers interact with each other, their guna compatibility comes into play. If the guna are compatible, then interactions between them are strong and consciousness is focused on that interaction due to the compatibility. If the guna are incompatible, then interactions between them are weak and consciousness is defocused from that interaction due to the incompatibility. Distance and proximity are thus created due to focus of consciousness. When we focus, then something is proximate. When we defocus, then the same thing is distant. Focusing and defocusing of the consciousness is the cause of the strength of the interaction and then of proximity or distance. This focus of consciousness is itself the result of three factors. I sometimes call these three mechanisms relation, cognition, and emotion. Let's illustrate this by an example and then we will try to generalize the concept. Take the case of a boy studying. If the parents take away entertainment from the boy and forbid him from playing outside, then the boy is forced to pick up the books because there is nothing else to do. This is relational cause. Then if the boy is truly interested in gaining knowledge, he may pick up the book because his mind is inquisitive, curious, and in search for knowledge. This is the cognitive cause. Finally, the boy may study his books because he thinks that his future will be brighter because of that study. This is emotional cause. The examples I've used here are just illustrative. The boy may study out of a sense of duty towards his teachers rather than out of a sense of compulsion. Similarly, duty will be called a relational cause in this case. The boy may focus on the subject where he is getting bad marks rather than the subject that he is inquisitive about. Then this choice of subject based on the marks will be the cognitive cause. The boy may study because he is afraid of being reprimanded by his parents rather than because he thinks it will make his future better. Then his fear of reprimand will be the emotional cause. In this way, there are three broad categories of relational, cognitive, and emotional causality that bring the boy close to his books. These are broad categories with many possible subdivisions. Each of these three is sufficient to cause the boy to study. For example, the boy may study exclusively because he has nothing else to do, or because he is inquisitive, or because he thinks that it will make his future brighter. But the studying gets much better if all three factors are favoring studying, namely, that there is nothing else to do, that the boy is curious, and he is convinced that he will have a much better future because of it. Similarly, each of these factors can be stronger or weaker. By the combination of the varying strengths of these three factors, a net strength of engagement is caused, which then creates proximity. Thus, proximity is the result of an observer's engagement with some reality, and distance is the result of an observer's disengagement with some reality. Since each of these three factors can vary, therefore, the process is not deterministic. It doesn't mean that the process is random or probabilistic. The process is still scientific, rational, but because it depends on more than one factor, and our scientific models are not accustomed to deciding an effect based on varying strengths of three causes, therefore it can look random to us. To understand this alternative causality, we have to think of observers and not inert objects. Therefore, if reality is modeled as observers, then the alternative ideas of proximity and distance become very easy. Once we understand the basic process of proximity and distance created through the conscious process of focusing and defocusing, that is in turn controlled by three classes of relational, cognitive, and emotional causes, then we can talk about the curvature of space and time. The basic principle of curvature is that observers always prefer to focus on some things and defocus on other things. They might be relationally equidistant from a person, but a preference for some and rejection for others, the equidistant things seem closer and farther. Curvature is the result of greater and lesser proximity to things that are not factually farther or nearer. A person focuses on something and defocuses from other things. This focus and defocus creates proximity and distance. The perceived distances to some things reduce and the perceived distances to other things increase. This is just perception and not reality. This process occurs not just at the level of human consciousness, but at every level of reality, including atoms, that humans cannot control because the entire reality is simply observers. As observers are attracted and repulsed, or attached and detached from each other, the apparent distance between observers is continuously increased, decreased, curved, or straightened. This curvature of space, along with increasing and decreasing distances, is the result of the interaction between observers through prana. We don't need a force called gravity to bend the space. Prana works instantaneously, due to which consciousness can instantly know anything. The body doesn't have to travel to a remote location to know. The mind and senses can also travel and perceive the remote reality due to the effect of prana. Therefore, no time is consumed in traveling as postulated in relativistic theories. I will come to the problems of assuming a light propagation speed in just a moment. Right now, I will focus on the fact that our minds can instantly think of anything, and that instantaneous thinking brings that thing being thought into immediate perception. Since a common causal process must apply to the mind and the senses along with the body, therefore the mechanisms of body interactions must also be based on the effect of prana. The distance and proximity perceived are now the results of a cognitive or perceptual bias in each person that prioritizes something over other things. The distances and proximities are the result of this cognitive bias. The bias itself is the result of three categories of causes, one of which is relational causation, which means that while waking, we see those things in proximity because they are being forced upon us due to the present circumstances. However, each person can also daydream, and then he will not see the things that he normally considers to be surrounding him. By changing his bias, he can also see other things. Classical physical theories have assumed a constant distance to things and calculated the strength of force based on that fixed distance. We can, however, invert that position and say that distance is the result of the strength of interaction. The relation between strength of force and distance will remain intact. However, the strength of force is now the cause of the distance rather than distance being the cause of the strength of the force. With that inversion, we can reconcile the interactions of the bodies with the interactions of the senses and the minds. If distance is fixed, then our senses and mind cannot see what they see during daydreaming. But if distance is the result of an interaction, then the distances between bodies, senses, and minds can be defined in a consistent manner. All distances can thus be said to be outcomes of conscious focus. Strong focus creates proximity, and weak focus creates distance. When something is seen as a result of focus, other things are not seen, which is precisely like they were infinite distance away. The basic property of being far from something is that we see it in an abstract manner. Sometimes, when we are far from something, we can see the whole, but we might not see the parts. For instance, if we were standing far from a person, we would notice the outline of the body and whether the person is a man or a woman. But we will not notice the precise texture of their dress or their facial features. The basic property of being close to something is that we see it in a detailed manner. If we get close to something, then we can see the parts, but we might not see the whole. For instance, if we were standing very close to a person, then we can notice the precise facial features and the texture of their dress, but we might not see the whole body. Thus, proximity is not just about the distance to something. It is also about how minutely we can see that thing. Similarly, distance is not just about the length of the gap between things. It is also about the fact that we don't see the details, although we can see the whole thing. The semantic view is anti-reductionist, which means that the whole is not reducible to the parts. There is indeed a whole distinct from the parts, quite like we call someone a man even if he is missing a finger or a leg. The manliness of the man is not reduced when a finger is removed because the man is the whole and stands apart distinctly from the parts, namely the finger or the leg. The whole and the part are joined together in an inverted tree structure such that if the whole is the branch, then the parts are the twigs and the leaves. Therefore, when we see something from a distance, we interact with the branches prominently and perhaps with some of the twigs. If we get slightly closer, then our interaction with the twigs increases and that with the branches reduces. If we get even closer, then our interaction with the leaves will be strong, that with the twigs will be weaker, and that with a branch may not be present. The property of distance is correlated to what we call the size. If the distance reduces, then the size grows. This effect is achieved by progressively interacting with the trunks, branches, twigs, and leaves. This phenomena is talked of by photographers in terms of two properties called contrast and brightness. The whole appears to be bright and the parts appear to be dim. That is because when we see the whole from a distance, it must be bright for us to see it from a distance. We cannot see dim things from a distance. Similarly, even as the parts are dim, there must be a higher contrast between the parts for us to see them as separate things. If the parts were not of different contrasts, then we will not see the distinction between the parts. Therefore, going closer to something is also about increasing contrast and decreasing brightness. Conversely, going farther is about decreasing contrast and increasing brightness. Photographers thus talk about three properties of color, namely hue, saturation, and brightness. In physics, hue is called frequency and brightness is called amplitude. These two are not enough to create contrast. For example, white or black must be mixed with the hue. We can create contrast even with a single hue by mixing black or white in the color. Thus, going closer means increasing mixture of black and white with a hue along with decreasing brightness. Going farther means decreasing mixture of black and white along with increasing brightness. By mixing black and white, the darker shade goes in the background and the lighter shade comes to the foreground. This is contrast, and it is a natural property of conscious perception that we put lighter shade in the front and the darker shade in the background. A room colored with lighter colors naturally looks bigger, and that colored with darker shades naturally looks smaller. This is apparent size and distance, not the actual size or distance. But appearance is very important for us to see the contrast. Hence, going closer also doesn't mean seeing all parts equally close. It means seeing some part to be closer than the other parts. We will now turn to the measurement results on speed of light. The basic problem of light is that all measurements of light speed use mirrors in some form. Mirrors in classical mechanics were reflecting and refracting light. But after the advent of quantum mechanics, all reflection and refraction phenomena have to be replaced by absorption and emission of light particles, which is not a deterministic process. A photon may be absorbed now and emitted after some time. That time is not fixed. Hence, all light measurements become indeterministic. And yet, we observe constant speeds of light. Similarly, light speeds are contrary to quantum entanglement, also called non-locality. Therefore, light has to be rethought to get an understanding consistent with both experiments on light speed measurements and quantum phenomena. If distance is the result of interaction, then the constant speed of light is the result of the fact that strong interaction produces proximity and the interaction takes lesser time. Meanwhile, weak interaction produces distance and the interaction takes more time. Therefore, if we divide the distance with time, the speed will always appear to be constant. Thus, the constant speed of light becomes trivially easy when distance is produced as a result of conscious focus, because that interaction creates both distance and duration being measured. However, assuming the light is traveling in space is seriously problematic for quantum mechanics because photons are emitted randomly. If a light beam is sent toward a mirror, then it has to be absorbed and then re-emitted. There is no such thing as reflection in quantum mechanics. It is only absorption and emission. The delays between absorption and emission are also not fixed because they are governed by probabilities. The round trip time of light is therefore not fixed. Assuming that it is fixed is itself contrary to quantum probabilities. Similarly, constant speed of light is a big problem for entangled quantum particles because changing the state of one quantum changes the states of the other quanta entangled with it. There is only one reasonable assumption, which is that light travels instantaneously. The delay in sending and receiving a light beam of light has to be attributed to something other than travel. That alternative is absorption and emission. In current physics, we assume that the propagation of light takes time, but the emission and absorption are instantaneous. We can invert that proposition and say that emission and absorption take time and propagation is instantaneous. This immediately resolves the problem of entanglement because light propagation is instantaneous. It is also consistent with the idea that the mind and the senses can instantly daydream, that the mind and the senses see actual dreams that look like the waking experience. Finally, this alternative is consistent with all the observed facts about speed of light. When quantum entanglement and constant observed speed are reconciled with daydreaming, then the idea of light propagation speed can be rejected. With this rejection of propagation speed, the delay in reception is the result of the delay in absorption and emission. To take an easy example, let's suppose that there are three people, A, B, and C, talking to each other. A and B are very interested in talking to each other, but not to C. If C asks a question or interject, A and B respond after a delay because they are preoccupied with each other. As a result, C feels left out as if he is not part of the group and he perceives a greater distance to A and B. This simple psychological fact can be used to illustrate length contraction and time dilation. Suppose that A is an observer moving toward a light source B. A and B have a strong interaction that progressively gets stronger, due to which distance between them continuously reduces. Meanwhile, C is a stationary observer. He gets responses from A and B slowly. He infers that A and B have gone farther and both have shrunk in size. Meanwhile, it takes longer to receive the response from them. Therefore, time has dilated. This is not just from the perspective of C. The same thing is experienced by A and B as well. As we have talked of in the previous video, a traveling person feels tired. Time appears to pass slowly when we are traveling. The journey looks longer and exhausting. Therefore, even the moving observer feels that time is dilated and the length is contracted because during traveling, one experiences changing facts while during the stationary state, one experiences just one fact. If we model these facts as information being exchanged between a sender and a receiver, then information transfer is reduced when the next experience is exactly like the previous experience. That information transfer increases dramatically when the next experience is different from the previous experience. This fact is used in all modern day electronic video processing, where the data transferred at each moment is just the incremental change to the previous data. When there is no change, then the incremental data is very less. When there is change, then the incremental data is bigger. Therefore, a moving observer receives more data in a short time, while a static observer receives less data during the same time. When more data is processed quickly, then length is contracted and time is dilated. Even as relativity says that a stationary observer is moving from the perspective of a moving observer, this is not factually true. The stationary observer doesn't get tired and doesn't feel that time is passing slower than normal. That is because the incremental information transfer to the static observer is zero. Relativity models observation as a physical interaction, while the semantic view models it as an information transfer. Incremental information is zero when the observer is static. The incremental information is huge when the observer is moving. Therefore, the relativistic equivalence is false, but time dilation and length contraction are true. Since physics only measures length contraction and time dilation, the measurable claims are verified, and so the dogma of equivalence is also taken to be verified when it is not actually verified. If we take the semantic view, we can confirm that length contraction and time dilation are true and the relativistic equivalence of observers is false. Thus, a moving observer can know if he is traveling by comparing his former state to the present state. This comparison is not understood in the case of physical instruments because we suppose that an instrument has no psychological state or memory of that psychological state. By disregarding the method in which we can know the difference between moving and stationary observers, relativity creates the illusion of relativistic equivalence. The problem of faster and slower absorption and emission of information is talked about in the Vedic texts as manovega, or the speed of mind. All minds don't have equal speed. Some minds can grasp difficult concepts quickly, and other minds take time to understand the same idea. Therefore, manovega, or the speed of the mind, is the capacity of the mind to absorb new ideas. This absorption is relative to what the mind already holds. If the mind is already well informed, then it can grasp new ideas very quickly. Those who can absorb this new information quickly have a faster mind. Those who can absorb these ideas slowly have a slower mind. Now, the transmission of information doesn't depend on the constant rate of propagation. It rather depends on the capacity of the mind to absorb new information. The concept of manovega, or speed of mind, can be extended to the senses and the body. Some senses can visualize something very quickly, while other senses cannot visualize it as well. Some senses can visualize viscerally, while other senses can visualize hazily. Finally, some body can move to a new place very fast, while another body moves very slowly. The concept of speed of mind applies equally well to the mind, the senses, and the body. However, constant speed of light certainly doesn't apply to the mind and senses, and even as it applies to bodies, it is inconsistent with quantum entanglement and probabilities. Therefore, all things considered, the speed of light is not about light propagation, it is rather about light emission and absorption. Every scientific theory is built on assumptions or axioms. If the axioms are false, then the theory is false. However, all axioms can be true in some cases and false in other cases. If we confine ourselves to the cases where the axioms are held true, then we can say that the theory is true in those specific cases. But if we try to find the exceptions to those axioms in other cases, then we can also falsify the theory. A true theory is only that whose axioms are universally applicable. The axioms of Einstein's theories of relativity are not universally true. As we have discussed, Einstein's two theories of relativity make four assumptions. The first assumption is that the speed of light propagation is constant. The second assumption is that even the effect of inertia, which Newton had postulated as the backward push we experience while accelerating forward, is basically a gravitational effect, such that the distinction between the inertial and gravitational masses which had been created by Newton is false. The third assumption is that space and time have no meaning other than the instruments by which we measure it, because all words have to be understood in terms of measurable properties rather than pure concepts. The fourth assumption is that all observers are equivalent, such that we can never call one observer's measurement true while we call other measurements false. All these four assumptions are false, but let's examine them in greater detail one after another. The problem with the constant speed of light is quantum mechanics. When light is emitted probabilistically, then all round-trip measurements of delay are problematic. We could still do a one-way measurement of light speed, but it is not done because it requires two clocks which are not guaranteed to be synchronized at the point of measurement. Therefore, one-way measurement suffers from the problem of clock synchronization, and two-way measurement suffers from the problem of quantum probabilities. Similarly, there is a well-known problem of quantum entanglement, which has been verified many times, and it indicates instantaneous action. Therefore, a constant speed of light cannot be elevated to a law of nature, as Einstein did. We have to rather explain why light is measured to have a constant speed in all directions. The reason, as we have discussed, is that conscious interaction produces both observed distance and duration. Since one cause produces two effects, therefore, when distance is divided by duration, a constant speed result is produced. The simple problem is that when we call what we call distance or space is not a real thing. It is a fiction created by conscious interaction. Therefore, all assumptions about constant speeds in this fictional space are also fictions. The foundation of relativity, which is the equivalence of all observers, is one of the greatest cultural and scientific myths. In the last video, we talked about how this myth came about due to the shifting of power from some elites to the broader society. The fact is that this shift has never been complete. Every society still has elites, and yet most people have the illusion of thinking that they are equal. The same problem exists in physics too. The reference frames are not equal because observers in each frame can tell the difference between stationary and moving. For example, if a person drives in a car on an empty road, according to Einstein's relativity theory, there is no way to say if the car is moving forward or the ground is moving backward. This is a myth because there is a fuel tank in a car and a meter on the car's dashboard which indicates the amount of fuel in the tank. The observer just doesn't have to look at the ground to say that it might be moving backwards. He can also look at the dashboard to say that his fuel is decreasing, and there is no rational explanation for that except to say that the car is the one moving instead of the ground. But relativity theory disregards this simple technique used every day by millions of people. By restricting the observation to that of the ground and removing the observation of the fuel tank, relativity comes up with the myth of equivalence of all frames. It is just as false as the myth of equality in society. Even if we were flying in an aircraft and had no access to the dashboard in the cockpit, we can still know that we are traveling because we get tired by traveling. Everyone who travels feels more tired than everyone who is stationary. They don't have to look out of the window to realize that they are tired. This is first person confirmation of the non-equivalence of traveling and stationary. Nevertheless, the principles of length contraction and time dilation are still true. They are just not the result of frame equivalence. As we have discussed, they arise as a result of conscious interaction, when attention is continuously shifted from one thing to another during motion, but the rate of attention shifting is very low when we are stationary. Therefore, a moving observer undergoes time dilation and length contraction due to a different reason than supposed in relativity. Even as the assumption is false, the result of the assumption is correct, and it has to be explained in a different way as we have done in this video. The whole point of doing a measurement using a standard is that the standard is fixed. It makes no sense for us to call something a meter if the length of that meter is not constant. We cannot say that two people bought 1 kilogram of flour if that 1 kilogram is not the same for different merchants. But this is precisely what happens in relativity. The meters are contracting and the clocks are dilating, and still we measure the distance in terms of meters and duration in terms of clocks. This is the fundamental refutation of any kind of objective knowledge. Standards-based measurements make sense only when there is one reference for that standard. Generally, standard meters and clocks are placed in standards bodies to serve as the reference. A standard makes no sense when we know for a fact that they are not constant. Therefore, the supposed relativization of standards is also the refutation of objective knowledge. As we discussed in the last video, objectivity in both public and private matters went out of the window during Protestant Reformation and Enlightenment. Although it was supposed that the resulting relativization was confined to the mind and not to the body. But in relativity theory, relativization entered the realm of the body as well. Certainly, the relativization of the body is less drastic to the relativization of the mind. But this is a matter of degree and not a matter of principle. As a matter of principle, both mind and body are relativized. Therefore, to solve this problem, we have to talk about a universal observer rather than infinite relativized observers. The observation of one observer is the perfect truth, and the observation of the other observers is not the truth if they are moving relative to the universal observer. If the relationship between the universal observer and the other observers is fixed, then the opinions of the individual observers can also be trusted. But if the relationship between the universal observer and the individual observers doesn't exist or is changing, then no knowledge claim can be called a truth claim. It is simply the personal and private opinion which may be less deviant than ordinary opinions, but it is deviant nevertheless. As we can tell, the reintroduction of a universal observer has religious overtones. But this reintroduction is not confined to the mind, as was the case in Protestant and Enlightenment thinking. Rather, the universal observer is necessary even to make objectively true claims about the body. All relativized claims are also subjective and deviated opinions and cannot be called true. Finally, the equivalence of inertial and gravitational masses is easily refuted on the same grounds as the relativistic equivalence of observers moving at constant speed relative to each other. Almost everyone has heard of people going bungee jumping or skydiving. People are doing it because free fall is not the same as being massless or without gravity. When a person does bungee jumping or skydiving, he gets an adrenaline thrill. That doesn't happen to people living in space stations. A person can live for months in a space station, but if a person skydived or bungee jumped continuously for months, then he would most likely fall sick and die. When two scenarios are not equivalent, then what is the basis of relativistic equivalence? The simple answer is that science operates by removing observers, replacing them with meters and clocks, eliminates the possibilities of checking simple things like the gasoline left in a fuel tank or the temperature of the body undergoing free fall, and then claims that two frames are equivalent. Oversimplification is the method of science. All scientific theories begin by making simplifying assumptions, getting some success in a limited domain, and then extending that success to the whole of reality, disregarding all the obvious discrepancies. For example, if we were to say that relativity is false because we can know if a car is moving by observing the fuel tank, then most people will just disregard it because their theory is relying only on a meter and a clock rather than a fuel tank. In their oversimplified picture of reality, there is no possibility of anything having a fuel tank meter. Nobody has the mental or sensual capacity to know what a meter and a clock cannot detect. By such oversimplification and limited success, a great hubris in science is produced, which leads not just to false claims, but also immense arrogance. One symptom of this arrogance is that scientists claim to have better knowledge than everyone in the past. They don't know that everyone's past was not as bad as one society's past that was making ridiculous and false claims for thousands of years before some sanity was brought about by science. But that doesn't a priori mean that every society was making similar types of false claims. We have to study the claims, analyze them properly, test them against all the modern science, and then we can pass the judgment. But arrogance prevents any analysis before passing a judgment. Of course, the result of hubris is always foolishness. Modern cosmology is among the foolishness because it rests completely on relativity theory, although every single assumption in relativity is false. Having established this falsehood of the assumptions in this video, we will talk about an alternative semantic cosmology in the next video, where all principles are based on conscious observers rather than inert objects such as meters or clocks.